Hello, in this section, 7.2, we're going to be going over analyzing data. So one of the things that we like to do with data is we like to first collect data, second, describe data, third, analyze the data, and then finally, fourth, we try to make some sort of a conclusion. That way we can speak intelligently about the data we've collected. Now, the one thing we have to remember is no matter what, the data that we collect must be collected responsibly. Meaning, standing outside of an ice cream shop and asking people do they like the ice cream might not be the best place because everybody drove there to get the ice cream. So there's a high likelihood that they're going to enjoy the ice cream that they drove that far to go get. However, on the other side, if you were to just send out a random question, like a survey or something like that, I was gonna say like a questionnaire, but if you send out a survey or something like that, and people reply back, you may get a little bit, and I'm using that phrase very loosely, a little bit better response and a better idea of the actual data that you've collected. So let's hypothetically say we've already collected the data. Now what we want to do is we want to start to describe and analyze the data. Okay? So there are three ways to find what we call the measure of center. And many of you have already heard of these three ways. The first way that we like to describe the data is by calculating what we call the mean. All right. Now, many of us know this as simply the average. The other way, or the next way, would be the median. Okay. An easy way to remember this, or maybe you've heard of this before. This is literally or physically. Oh, can't spell today. The number in the middle of a sorted list of data. All right, so the most important thing about the median is you have to sort the data. All right, that's really important. And then the third way is going to be the mode, okay? And this is the number repeated the most. Now, each one of these has their advantage and disadvantage, okay? And as I go through each one of them, I will tell you, okay? But first, let's talk about the mean. Now, the mean is a numerical measurement about the set of data. Now, the mean does have a formula. So the mean has this special symbol. This is called X bar. And this is equal to the summation of X divided by N. Now, I'm going to be honest. None of these symbols make any sense unless you know what they are and you know what they represent. Therefore, on the far right side of your screen, X bar is the mean. This letter E is called sigma, and it just means to add. That's all it means, is to add up. X are going to be the data values you collected, and N is the total amount of data values. So now that we know what each one of these symbols represents, hopefully this formula makes a little bit more sense. Okay? Now, the mean is definitely the one that we use the most. Okay? So it's definitely most used, and it requires what we call quantitative data, meaning numbers. Let me write it underneath. Numbers and measurements. Okay? Now, one downfall of the mean all right, cons. The mean is sensitive to outliers. All right, it's very sensitive to outliers. So, like, for example, let's say you were looking at all these prices of food, all right? And they're all around the same price. I mean, you have an estimation of what they could be. But then one of these items is like 5 times the cost of everything else, okay? That would be an example of an outlier, and that would affect the mean dramatically because it's very sensitive to outliers. Another con, all right, would be sometimes the value itself doesn't make sense. All right? And in this case, it could be something like measuring the average shoe size. All right? You don't go to the store and say, "Oh, I would like a shoe. I love this shoe right here. It's a Nike shoe. My shoe size is 7.2." Like the 0.2 doesn't make any sense. Even though when you've collected all this data, that was the average size of the shoe. All right? So just make sure you're careful with interpreting these numbers. What I would like to do is go ahead and do an example of this. Okay? So let's find the mean for the following data set. So we have 12, 13, 17, 19, 19, 19, 20, 21, and 21 again. All right? So remember, to calculate the mean, it's x bar equals the summation of all the data points divided by n. So if you're watching the screen, as I highlight 12, 13, 17, all these numbers, they all represent the letter X. So what we're going to have to do is we're going to have to take each one of them, add them up, and then divide by the total number we have. So let's do the easy part first. Let's find a letter N. So we have 1, 2, 3, 4, 5, 6, 7, 8. Looks like we have 9 data values. So N is going to equal 9. So far in our formula, X bar equals a big numerator divided by 9. So the next thing we got to do is just add up all these data values here. So I'm going to get out my calculator here. Let's see if I can do this real quick. Try to maximize this and get the screen here. There we go. Now I'm going to have to click on each one of these again. All right. So let's go ahead, let's add them up. I already forgot the numbers. 12, 13. Okay, there we go. So we're going to do 12 plus 13 plus 17 plus 19, and we have 3 of those. So there's 1, 2. There's my third 19, 120, and 2 21s. All right, so the numerator turns out to be 161 divided by 9. And I'm going to copy and paste this into our notes so we can see it. Perfect. So we end up getting 161 over 9, which is approximately 17.9 rounded to 1 decimal place. And we have our calculator screenshot here. That just shows what we did. I definitely encourage everybody to be using a calculator. It just makes the little tedious math easier for us. So that is how we find the mean. Now, sometimes you may come across a problem that's not exactly straightforward as this one is. All right, so I'm going to show you one from your homework, okay? So our numbers may be the same, and if they are, great. But if they're not, then just follow along with your problem whenever you get there. But Willie has an average mean of 82.6 on the first 5 exams. What is the least he can score in order to have an average of 85 for all 6 exams? So when you become a teacher, you're gonna get this a lot, and you're gonna go, oh, come on now. Students always want to know, what do they need on a certain test to get a certain grade? And I mean, definitely you always want to help, but if you teach this in class and then they come back and ask you, it's like, well, I taught you this in class, go back and figure it out on your own. Now, I'm not going to do that to you here. I'm going to help you out with this. But the first thing we need to figure out is this sentence right here. Willie has an average of 82.6 on the first 5 exams. All right. Now, here's what we know. We know the mean is equal to the summation of x over n, which means, in this case, x is going to be the test scores. We know what Willie wants. Willie wants an average of an 85, all right? So Willie wants this over here. He wants the average of the 85. We also know that how many tests were on there? Well, there were 6. So we know this is going to be divided by 6 somehow. What we don't know are the individual test scores that Willie had. However, that first sentence gives us a lot of information. They said the average or the mean of the first 5 exams is an 82.6. So what we can do is we can find the total points for the first 5 exams. In other words, we don't have to know what the individual scores were for each test. But what we could find is for the first 5 exams, we know that the average was 82.6. We don't know the total points, but we do know that there were 5 exams for that. So, if you look at what I have here, we can figure out the total points just by saying, well, we're going to multiply both sides by 5. Now I'm doing this off camera. 5 times 82.6 is 413. So we know the total points for the first 5 exams has the total 413. So in the upper left or upper right hand corner of your screen, I'm going to erase all of these and say, well, the total points for the first 5 exams has to be 413. So now if you look, I have, and I'm just going to rewrite it down below. We have Willie's score that he wants, 85. We know the total points for the first 5 exams were 413 points. This last X sub 6 just means the 6th test or the 6th exam. And we're going to divide it by 6 because that's the total amount. To solve this, we're going to multiply 6 by both sides first. By doing that, on the right-hand side, we reduce the 6's. Don't know why that went away. On the left-hand side, 6 times 85 is 510. And finally, to find that 6th exam, we will subtract 413 from both sides of the equation. So 510 minus 413 would be a 97. And I always like to kind of write a little sentence. Willie would need a 6th exam score of 97 to obtain the 85% score he wants. All right, and that's how we solve that one. So you're going to have a problem like this in your homework. Zoom out here a little bit. So you're going to have a problem like this on your homework, like I said. And just make sure you just think your way through it. Take your time. There's no rush. All right. Next. The median. Okay. Now the median, we already stated, is the number located, in the middle of sorted data. All right. So, what are some pros to this? All right, well, some of the pros, we are not affected by outliers. All right. Second, it is the midpoint. All right, it is the midpoint of the data. All right, so like I said, it's the exact middle. The mean can shift left and right a little bit, especially if you have an outlier. But this median is boom right in the middle. What's one of the cons? It's not always appropriate. Okay, so like for example, if you look at like a team's winning percentage, all right, if you look at the winning percentages of all teams, that's not a really good representation of the median, because there are some teams that win all the time, and there are some teams that never win. So when you look at that situation, all right, you will sit there and say, well, let's think about this. If a team wins all the time, they will have a winning percentage of 100. Then we'll call this the Pittsburgh Steelers. And I know they don't win all the time, but let's hypothetically say they do. Then you have the Browns. Now, as a Pittsburgh Steelers fan, one of our rivals is the Browns, and we love to beat the Browns. So let's just say the Browns win percentage is 0. They never won anything. What the median tells you is right down the middle would be 0.5, all right, or 50%. And that right there does not give us a really good representation of what's happening in this scenario. What's really happening is one team is winning all the time and one team is losing all the time. All right? It's not a 50-50 shot here. So let's go ahead and let's look at an example of the median. Now, there are two cases we got to worry about. So when we calculate the median, we have two cases. The first case, case 1, is when n is odd. Now remember, n is the number of data values. All right? So when n is odd. So here's a situation here. I'm gonna sort the data. All right. So if you notice here, I have 5 data values, and the number that is physically located in the middle is this number 3. So we would say that this is the median. All right, very straightforward, nice and neat. The second case is when n is even. Now in this scenario, if I use basically the same data values, except I add one more so it's even, the physical middle location is right here. But as you can see, there's no number there. So what we do is we take those middle two numbers and we find the average for them. So 3 plus 4 would be 7 divided by 2, or 3.5. Okay? Now, as I said earlier, all right, the mean is sensitive to outliers. The median is not sensitive to outliers. So let me show you an example here. We're going to compare the mean versus the median with outliers. So, very simple problem. 1, 2, 3, 4, 5, 500. So hopefully everyone's sitting there looking at this number and going, okay, yeah, definitely an outlier. But if I were to find the mean, I would have to add all these values up. So 1 plus 2 plus 3 plus 4 plus 5 plus 500. And then divide it by 1, 2, 3, 4, 5, 6. So I'm just going to take my calculator off screen here. 1 plus 2 plus 3 plus 4 plus 5 plus 500 gives me 515 divided by 6, which is approximately 85.8. Now ask yourself, is that a very good representation of the data collected? Does 85.8 make any sense when the majority of our numbers here are 1, 2, 3, 4, and 5, and then you got 500 all the way to the right? All right? So I'm going to let you answer that yourself. Now, if I were to find the median, let me use a different color. All right, if I were to find a median, make sure the data is sorted. Now the number physically in the middle will be right here. So I add these two. And we already found that this is 3.5. Now, ask yourself, in this scenario, does 3.5, is that a better representation? I would say absolutely it is. This 500 is the outlier. If you were doing a research study, you would have to address the outlier saying, hey, this value that we collected so far off to the right, it's an outlier. Therefore, we are not going to include this value in our when we analyze the data. And that's acceptable. You could totally do that. But you have to demonstrate that it is an outlier. Okay? The last measure of center I'd like to go over. Oops. Get my black marker out again. The last measure of center is the mode. Okay? Now, the mode is primarily used for what we call let me use a better word. Qualitative. You're gonna hear that word a lot more. All right. we use the mean, or I'm sorry, misspoke. We use the mode for qualitative data. All right. Another way to say that is categorical data, meaning you could fit it in the categories. Now, do not assume all numbers are quantitative. Not all numbers are quantitative. Even though they're numbers, and the word quantitative means quantity or numbers, not all numbers are quantitative data. Here's an example. Let's say we are in a room of, 10 people, who cares? And our goal is to collect the different area codes for the people in the room. All right. Now, area codes are numbers. So like I said, let's say we have 10 people. All right, here are 10 people right here. Here are their area codes. They are all numbers. However, these numbers are not quantitative. All right? They are not measurements. These numbers represent locations. That's a category. All right? So these are categories. Now, in this scenario, the mode, and as we defined it above, actually, I didn't even define it above. The mode is the measurement or number repeated the most. And I did define that. I defined it all the way at the beginning of this. I forgot. So in this situation here, notice that 412 is by far the most dominant, highest frequency area code. So we would say the mode is 412. Okay? Now, how about some pros for the mode? Well, some pros. It's easy to find the common. 'Cause, 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 'cause So it's easy to find the most common data value. All right, it's the number repeated the most. All right, if we were to graph this, this is very easy to graph. Very easy to graph. All right, we could do like a frequency chart here where we would have the different area codes listed underneath. So let me copy and paste these so I can see them. All right, so I would do an XY. There we go. Frequency. And the measurement. So we would have 412. Let me put it over here a little bit more. 412, 848, 613, 724. Call this 2, 4, 6, and 8. So for 412, we have 1, 2, 3, 4, 5. So it'll be like right here. For 848, we only have 1. For 724, we have 1, 2, 3. And finally, for 613, we only have 1. So there you go. There's your graph right there. You can easily condense the data into a nice picture. All right. What are some of the cons? Well, some of the cons. You might be far from the center. All right. Might be really far from the center of the data. And 2, you could run into a situation where you have data that is multimodal. All right, now, what does multimodal mean? Here's what an example of multimodal is. Here we have data here, and this is what we call trimodal. And that's because the numbers that are repeated the most are 1, 3, and 5. So 1, 3, and 5. So in this situation, it would be maybe really difficult to make a decision because it's multimodal. This is trimodal. All right. The next thing we're going to go over is basically how we do your grades. Weighted averages. Now, with weighted averages, okay? With weighted averages, each category has a different weight or value assigned to it. All right. So, for example, we're going to find John's grade. That's me, by the way. And this is exactly how I do it for your class. Exactly. All right. So what I do is I have 4 categories: homework, test, quizzes, and then a final exam. All right. And what I'm going to do right now is I'm going to pull up our syllabus. I'm doing it off on my computer, so you can't see it right now. but I'm going to pull up our syllabus right here, and I'm going to get the categories themselves. So let's see here. Let me scroll down. Homework is 20% of our grade. Tests are 40%. Quizzes, 15%. And then the final exam is 25%. So if you were to take all these scores and add them up, 20 plus 40 plus 15 plus 25, this would get you 100% of our grade. So visually, here's what's happening. Let's say we get a pie chart. 40% are going to be tests. All right. 25%. Let's go. We'll go like right about there. Is the final exam. 20% is homework. And then your quizzes are 15%. So this is how this is what a picture of your grade would look like. Now, the way that I calculate this is I will go ahead and I will find the average score for each one of these. So I guess obviously the final exam wouldn't be the average. It would just be the actual score itself. All right. But I go through and I find the average homework, the average for tests, average for quizzes, and then your final exam score. So let's go ahead and let's do this. So homework, my average homework score was a 94. My average for the quizzes, 82. My average for the test, 85. And then my final exam, 78. So how would I calculate my grade? Well, the weighted average is equal to the sum of the weight times x, all divided by the sum of the weights. Okay? So W would be the weight. Oops, let me write it underneath. Weight of each category. All right? So if you just look above, my weighted average, WA, is going to equal 94 times the weight of that category. Okay? So the weight of the category for homework was 20%. So it's 0.20 plus 82 times the quizzes. Quizzes were 15%. Plus 85 times our test. Tests were what? 40%? And finally, the final exam score times its weight, all divided by the sum of the weights, which this equals 1, but I'm going to write it out anyways. All right. So get out our calculator. I'll do this one on screen. Here we go. Let's turn it on. So let's see what we have here. We have 94 times 0.2 plus 82 times 0.15 plus 85 times 0.4 and finally plus 78 times 0.25. So my weighted average at the end of the semester would be 84.6. And that is exactly how we calculate all of your weighted averages in any college you ever go to in the world. It's the same exact process. All right. So that's going to be it for this video. If you have any questions, please let me know, and I will see you in the next one.